Hey, it's Mr. Shrum, and I am going to uh, show you how to actually use the resources in the field trip section of these units and how you can tie it into the assignments and the quizzes and review sections of these physiology units. But I think they're a nice way to supplement your learning instead of just clicking through the lessons, the PDFs, or the slideshows of these Edmentum lessons. But if we click here, Kids Health Ears, there is a section on one of the suggested resources, kidshealth.org, and this is specifically for teens, Teens Health, which is our demographic. And the section starts off with what are ears, what do they do? And we know that there are different sections of the ear. There are three, and together they work to collect sounds, take that auditory input, and then send them to the brain. And we have the outer ear, the middle ear, and the inner ear. So I'll play this short video and mute my mic.
The ears collect sounds and turn them into messages for the brain to interpret. They also send information about balance to the brain. Three sections of the ear work together to make this happen. They are the outer ear, the middle ear, and the inner ear. The outer ear is made up of the pinna and the ear canal. These parts gather sounds from the environment and funnel them into the middle ear. The middle ear takes these sounds and turns them into vibrations. Sounds that come into the middle ear hit the eardrum, causing it to move. The eustachian tube helps the eardrum to work well by keeping the air pressure balanced on both sides. When the eardrum moves, it makes three small bones, called ossicles, vibrate. The vibrations are then sent to the inner ear. The inner ear receives vibrations and changes them into messages that go to the brain. These messages are called nerve signals. The inner ear is made up of the cochlea and the vestibule, which includes the semicircular canals. The cochlea has fluid in it that moves like a wave. This happens when vibrations come in from the middle ear. The moving fluid causes hair cells to make nerve signals about sound. Semicircular canals also use moving fluid to create nerve signals that help with balance. Then, the signals from the cochlea travel along the auditory nerve. Signals from the semicircular canals go along the vestibular nerve. These two nerves come together and lead to the brain. There, the brain decodes the signals to get information about sound and balance.
All right. So an easy way to break these sections of the ear down is to think about what each section is trying to do. The outer ear is trying to take in sounds, right? The middle ear is this air-filled cavity, and its job, its primary function, is to turn those sound waves from the outer ear that the outer ear captures and turn those sound waves into vibrations. And then it sends them to the inner ear. The outer ear captures sound waves, the middle ear translates them into vibrations, and then sends them to the inner ear. And the movement, the vibrations, affect those very small bones, and those are called ossicles. And if you break the ossicles down further into their components, we have the malleus, which is hammer, that's attached to the eardrum, the incus or the anvil, uh, which is attached to the malleus, and the stapes. It's shaped like the stirrup, so you have the hammer, anvil, stirrup, which is attached to the incus and is the smallest bone in the body, the stapes. And in order to hear properly, you need the pressure to be equal on both sides of that eardrum. So when you're going down in elevation or you feel a quick air pressure change, you hear this popping sensation in your ears. So if you've ever flown on a plane or driven in more mountainous regions where the elevation changes quite a bit, you will experience this ear popping. And ears adjust thanks to the eustachian tubes that connect the middle ear to the back of the nose, and it acts as a pressure valve. So the pressure stays balanced on both sides of the eardrum. Very cool. All right, so let's rewind. You have the outer ear made up of the pinna or the auricle and the ear canal. It takes those incoming
Also send
incoming
middle ear and the
sound waves
inner ear.
here. So we have the pinna, the auricle, and that goes into the middle ear. Here's the eardrum. The pressure has to be the same, equal on both sides of this eardrum. Then the sound waves are translated into vibrations. These three little bones, the ossicles, vibrate. There's the cochlea, and then it's sent into the inner ear. And the inner ear from it takes those vibrations from the middle ear, and within the inner ear, it changes them into nerve signals. So you have sound waves translated into vibrations, translated into nerve signals, and those nerve signals are finally sent to the brain. Within the inner ear, you have the cochlea and the semicircular canals. The snail-shaped cochlea, you can see that here, looks like a snail. That changes the vibrations from the middle ear into the nerve signals that are then sent to the brain. These signals travel to the brain along a cochlear nerve, and this is also called the auditory nerve. The semicircular canals look like three tiny connected tubes, and it's their job to help you balance. The canals are filled with fluid and lined with those tiny little hairs, and when your head moves, the fluid in the canals sloshes around, moving those hairs. And then the hairs send this position information as signals through the vestibular nerve to your brain. And your brain interprets these signals and sends messages to the muscles that help keep you balanced. When you spin around and stop, the reason you feel dizzy is because the fluid in your semicircular canals continues to slosh around for a while, giving your brain the idea that you're still spinning even when you are not. Once the fluid stops moving, your dizziness goes away. And then finally, we have some steps to keep your ears healthy. Try not to stick things like cotton swabs and fingernails into them. Doing so can actually scratch your ear canal, push earwax deeper into your ear, and even rupture an eardrum. If you find yourself having trouble removing earwax from your ear canal, talk to your doctor. They can help you out with excessive earwax issues. You also want to protect your hearing. Turn down the volume on video games, TVs, and especially portable music players. Wear hearing protection like earplugs or protective earmuffs, headphones when you're around loud noises. If you go to a lot of concerts or you like cars, if you work on loud machinery, say in a manufacturing plant or construction site, hearing damage builds over time. It doesn't take long for problems to develop, and tiny earbuds can even harm your hearing as much as a large chainsaw because the source of sound is right in your ear. Um, I can show you some possible hearing protection. So we have these types of over-the-ear protection. That's more if you're working on like construction or very heavy machinery. Um, these can also work, these smaller ones, but the more decibels you're likely to be exposed to, the heavier the hearing protection generally is. But I'll show you some that I've used for concerts. These are more discreet. They're smaller. They fit in your ear. High fidelity earplugs. You're still able to hear the sound, but it just prevents the more harmful decibels or sound ranges from damaging your ear. So those are some good options um, that I would suggest to protect your ears. And we can also talk a bit about signs of hearing loss, how to protect your ears, and what are some of the signs that you may be experiencing some hearing issues or hearing loss. So if you hear a lot of ringing, buzzing, or roaring in the ears after hearing a loud noise, that's not a great sign, but it does happen. You can't control. And being around loud things sometimes. Muffling of sounds, that's also another sign. But you should definitely call your doctor. And if the doctor deems that you need to talk to an audiologist or a specialist that handles hearing issues and ear-related issues, that audiologist can answer your questions about using earbuds and protecting your ears. Doctors recommend the 60% 60-minute rule. So listen to music or play a movie or video game at no more than 60% of the maximum volume. Limit the amount of time you spend with earbuds in your ears to 60 minutes. Here's another way to find out if your earbuds are at a safe volume. Ask people sitting near you if they can hear your music. If they can, it's a sign that your hearing is being damaged. Turn the volume down until other people can't hear it. Keep in mind, too, that listening to music at a loud volume can make you unaware of what's going on around you. That increases your chances of an accident. So if you're riding a bike or driving, you generally want to keep the sound lower, just for awareness purposes and, of course, the health of your ears. What are some other options instead of the little earbuds? You can go retro, as this article suggests, and sometimes those over the ear headphones or the noise canceling headphones, those can help block out other noises. That way you don't have to turn up the volume on your music as loud because they cancel out other noise. Um, and they're also good for helping you study or completing homework if you're in a louder setting, but you just need to put some headphones in to block out some of the noise. Headphones that go over your ears can also damage your hearing if you use them too long or play music too loudly. They're just not as much of a risk as earbuds are. Having the source of the sound in your ear canal can increase the sound's volume by 6 to 9 decibels, enough to cause some serious problems. Earbuds exist because so many of us love music and to listen to things that we love. So protect your hearing so you can continue to appreciate music. So we talked a bit about this, and one of the words we didn't see in that other article is tinnitus. That is what that ringing or buzzing sound in your ears is called. It usually gets better over a day or two. So if you go to a concert and you're around very large sound systems, loud sound systems, you generally want to give your ears a break, right? Um, Tinnitus and hearing loss may not go away if you listen to loud music or hear loud sounds over and over again. Construction workers, airport workers wear ear protection. Lawnmowers, power tools, chainsaws, those are all loud enough to cause tinnitus and hearing loss. Some musicians have lost their hearing and have tinnitus, a real problem for someone who needs to hear to make music. That's why you may see more musicians wearing ear protection while they're playing. And here's more hearing loss reduction steps. Excuse me. Now we're going to switch it over to eyes. So we talked about ears. Now let's talk about eyes. Let me double check this article. Oh, well, that didn't work. So we have the eyes. I can also show you another video about sensory organs.
Let's learn about the eye. Our eyes allow us to see the
I don't know if this was the correct one. Of course, we have the crash course one. We can watch a bit about that and not look at these. This might be a shorter video for us.
In our previous video, we studied different parts of the human eye and their functions. In this video, we're going to roughly see how light propagates inside the eye and how we're able to see the objects around us. And for that, we will consider a simplified
This will give us
We
the
learned
general
that objects are
structure
visible
of
because
the
of the
eye.
light getting reflected from their surfaces. This reflected light enters our eyes and we see that object. What happens inside the human eye when the light rays enter it? What is it that helps us see the things around us? The human eye is roughly spherical in shape. What we're going to do in this video is understand the different parts of the eye in short, not in extreme detail. Let's begin. The outer layer of the eye is called the cornea. It's white in color and transparent. Transparent? Yes, it means that it allows light to pass through it. In fact, cornea refracts or bends the light passing through it. And much of the refraction inside the eye is done by cornea. But wait, it not only refracts light but also protects the inner parts of the eye. It acts like a tough front wall of the eye, protecting the interior of the eye from accidents and also does not allow foreign particles to enter. Okay, so this was all about the outer layer of the eye. Let's now talk about the things present inside. Behind the cornea, there's a dark muscular structure called the iris. Iris determines the color of the eye. For instance, when we say that a person has blue eyes, it means that the color of the iris of the person's eye is blue. Now there is a small opening at the center of the iris for the light to enter. Do you know what it's called? It's called the pupil. The iris actually acts like a shutter of a camera. It controls the amount of light entering the eye by enlarging or shrinking and thereby adjusting the size of the pupil. For example, when you focus the light from the torch directly into a person's eye, the iris shrinks. This is because the intensity of light is too much for the eyes to bear. The shrinking iris stops the unwanted light from entering through the pupil. And when there's less light, it expands, allowing more light to enter through the pupil. Okay, what happens next? The light that enters through the pupil falls on the lens kept behind. The lens is a convex lens. Convex lens is a lens which is thicker at the center than the edges. It's a converging lens. That is, it focuses all the light at one point. In a normal regular eye, this point is somewhere here on this inner boundary called retina. Why do I say a normal eye? Well, in a defective eye, this point of focus may lie either in front of the retina or behind the retina. We will talk about this defect of eye in our future videos, but first, let's go back to our normal eye where light is focused on the retina. Retina is at the back of the eye and marks the inner layer of the eyeball. Retina contains lots of nerve cells that sense the light. The nerve cells are of two kinds, namely cones, which are sensitive to bright light, and rods, which are sensitive to dim light. The message or sensation is then transferred to the brain along the optic nerve. Okay, let's quickly recap what we learned about the human eye. Human eye has a roughly spherical shape. The outer part of an eye, called the cornea, is a thick white transparent wall which protects the eye from accidents and keeps the foreign particles from entering inside. Behind the cornea, the colorful part of the eye, called the iris, is present. It has a small opening at the center called pupil. Iris controls the light entering through the pupil by contracting and expanding. Behind the pupil, there is a converging lens which focuses